Hi, this is Mr. Max with Sankofa Mathematics, and I am looking into differentiation. And this is going to keep us quite busy because I have over 18 questions. So, when we are done with differentiation, I'm going to share my work on integration. Okay, so I have a number of questions on integration that I'm going to explain in detail, and stand by for that. But today I'm doing differentiation. So the first question says differentiate y equals to 2x cubed plus 5 all over x with respect to x. So there's many ways you can do this. You can perhaps also separate this, put everything over x like so, and just to make it a little bit much easier, so this becomes then 2x squared, and this will probably become 5x raised to the power of -1. So I hope that you are quite familiar with the laws of indices and so on. So from here you can start differentiating with respect to x. So dy dx is going to be multiply 2 by 2, that gives you 4, subtract 1 from the power, multiply -1 times 5 will be -5, subtracting 1 from the power gives you -2. Now I'm just going to rewrite it nicely. So it's going to be 4x minus, well, it's 5 all upon x squared. Right, let's do the second one. Determine ds dt if that is what you get. So again, I'm just going to clean this function. So I'm going to have 7 over t minus, so you have got 5. Now that t that I have there is raised to the power of a half plus 3t. Well, of course, every one of these things is all over t. So we can go ahead and also write them separately. So this is 7 over t. Well, divided by t, when you divide something by t, is the same as multiplying. Let's see, it's the same as multiplying. So dividing by t is the same as multiplying by 1 over t. Okay, just to bring that up. So you have got minus, so that is 5 t raised to the power of a half. Well, of course, this should be divided by t, and then the last one is 3t all over t. Okay, so remember this is t raised to the power of 1, so I'll be definitely doing something over there. So at the end of the day, I have 7 over t squared. Then this is going to give me minus 5 t raised to the power of negative a half. This is what you get if you say a half minus 1. When you divide, the bases are the same. Subtract that, so that's going to give you 3. You can actually do more work further by supposedly saying this is nothing but 7t raised to the power of -2. Then I have minus 5t raised to the power of negative a half, obviously plus 3. Now I can actually find differentiators with respect to t. So I can now start with my sum and differences. So you're going to multiply -2 times 7, that gives you -14, of course. So ds dt is going to be -14 t raised to the power of -3, because you're subtracting 1 from the power. Multiply that, a negative times a negative gives you a positive value. So that's going to be positive 5 halves. And then that is t, subtracting 1 again from that is -3 halves. Okay, that's going to give you -3 halves. Okay, the derivative of a constant is equal to 0. So let's just clean this up a bit. So what I'm left with is going to be -14 t cubed. Okay, let's make sure, plus 5. Now here we go. So that's all over 2. So that says take the square root of t, And once you have the square root of t, then you will cube the result. Okay. So again, revisit how to do fractional indices. All right, so that's what that one is. Let's go to the next question. It says determine dy dx if you get that. So here I suggest maybe you rewrite this as, of course, x squared minus root x, of course, x squared minus root x. Just go old school and multiply that out. So that's going to be x raised to the power of 4. So that is that. Okay. And the next one will be this one here, x. It's going to be two of them, x squared. So it's going to be minus, well, you can write it as x squared root x. And then again, when you come here, it's minus x squared root x. And of course, once you multiply these two together, and you should be very careful here, you're going to get a positive. Now here's the thing, root x times root x is just going to be x. Right? So that's the same like the whole thing is same like x times x, which is giving you x squared, and you should know that the root and the square cancel each other. So basically this is going to be plus x. Okay, so we can clean it up a little bit further. So this is y equals to, so I've got like terms in the middle, that's two of those, minus 2x squared root x, obviously plus x. Now it's better looking, we suggest, unless you obviously want to do something about this root of x. So I'm going to still do it, then I say x to the power 4 minus 2 x squared multiplied by x raised to the power of a half, that is what the root of x means, plus x. So in the middle here, we have like terms or multiplying the same basis. You're going to add the indices. So it's going to be 2 plus a half, which is basically 2.5, or 5 upon 2. So this eventually gives me y equals to x to the power 4 minus 2x raised to the power 5 over 2. Remember, 5 over 2 comes from nothing but saying 2 plus 1 half. Okay, that's 2.5 or 5 over 2. Okay, plus x over there. Now I'm ready to differentiate x with respect, or y with respect to y. So it's dy dx is going to be 4x multiply, reduce the power. Multiply, you must be very careful here when you're multiplying here. So you're going to multiply 5 over 2 times negative 2. So you'd say 5 over 2 times, of course, negative 2. Of course, that gives you negative 5. So this is negative 5x. Now, if you reduce 1 here, it's going to give you nothing but 3 over 2. Remember, this is 2.5. So take away 1, it's going to be 1.5. So 1.5 is nothing but 3 over 2. Then obviously the derivative of this is just going to be 1. Okay, subtracting 1 from there. Of course, you can further clean it up by maybe writing it nicely, removing those negative indices and stuff like that. So this is minus 5. Then this is x, the root, square root of that. Remember, with fractional indices, the denominator is always the root, so hence the square root, and the numerator is always the power. So effectively, we are going to cube that, all right? And then you can basically say plus 1. And that takes care of that. This is basic stuff that you need to be able to differentiate quickly. Right, let's come to question 3. Question 3, the point A lies on the curve y equals to x squared minus 2x plus 2. Find the equation of the tangent. The moment you have words like that, the equation of the tangent, that means you have to do your derivative function. So I'm going to do that because what this is, differentiation, is you are basically finding the gradient of the curve at any value of x. So here we know what the value of x is 2, and the value of y is 2. So deriving that is going to give you 2x minus 2. Okay, so that's what you get. The derivative of a constant is obviously equal to 0. Now here's the thing. So this what you have here is called the gradient formula. So you can calculate the gradient of this curve at any value of x. Even if you had to find the gradient at 2, you can actually find that. So if I have to then find the gradient, so we say when x is equal to 2, of course that comes from my point that was given to me, point A, then you're going to have 2 times that particular 2 that we have calculated, so that's 4 minus 2. The gradient happens to be 2. So what this gradient is, this is the gradient of the tangent. So in a nutshell then, if I have to go old school, the tangent to that curve is going to be y equals 2. It's in the form of mx plus c. Now, we are using another equation where we say y minus y sub 1 equals to the m, which is the gradient, and then x minus x sub 1. So basically, if I have a point and I have a gradient, I can use this formula. Can also use this formula if you want to. Right, so let's use the first one. So now I said the gradient was nothing but 2x, but we do not know the y-intercept. But we know that that is the point. And we know from the information we are given that that point there is a tangent to the curve. So find the equation of the tangent to the curve at A. So that A, that point, it lies on the curve. And because it lies on the curve, it is also going to be a point that is being shared on that tangent line. So I can therefore go ahead and substitute my value for x and my value for y into my equation. So that's 2 and 2. So what this allows you to do is to find the value of c, okay? And the value of c will be y equals to 2x minus 2. So this is the equation in the form, in the gradient intercept form. This is the equation of the tangent. However, if I have to rewrite it, okay, you see that I've rewrite it using that. Suppose someone else was doing or using this formula. So you have a point and you have the gradient. So you just go ahead and substitute again. So we know, let's change this here. So we know that the y value is nothing but 2. So I'll have y minus 2, and the gradient happens to be 2 as well. And the x value also happens to be 2. So this lot of 2's, they kind of confuse you, right? Anyway, if you were to multiply out, you get 2x minus 4 over here and y minus 2. So eventually, it's going to be y equals to that 2x minus 4 plus 2 if you move that over. And guess what? You're going to get the same equation, which is y equals to 2x minus 2. So this is the exact same equation using this formula, which is the one that we're going to use quite a lot. So that is the gradient of, or that is the equation of the tangent, okay, at A. So what the question is asking, or the instruction is saying, find the equation of the tangent to the curve at A. Now we have that. Okay, so let me just bring in a little bit of technology. So what you have is that curve. So that's the curve y equals to x squared minus 2x plus 2. And let me just bring in that particular point that they are making reference. So they gave me a point, and the point that they gave is point A, which is the point 2, 2, as you can see. Okay, and then we have determined the tangent. The equation we calculated was the tangent, and you can surely see a tangent is a line that just touches the curve, never really ever passes it. So that's what we have over there. So now we have the tangent. That's the equation. Now, the next thing that we need to do, and I'll go back to the problem because it's divided in two parts. It says the normal to the, so we have to find the normal to the curve at A. So remember, the normal to the curve, we know the gradient of the tangent, we know that it's 2. So the gradient of the normal is going to be the opposite of this, which is a half, and it's going to be negative, such that the gradient of the tangent times the gradient of the normal should always give you a product of -1. The reason being that the tangent and the normal, those lines, they always are perpendicular. They meet at 90 degrees. Okay? Now, in any case, so now we know what the gradient of the normal is. So I'm going to use the same thing. So we're going to use y minus y is equal to m and then x minus x. Maybe we can say sub 1 just to make sure. So I'm still using that point A, which is the point 2, 2. And the important thing about this is the normal to the curve at A. So if I go back there, okay, that line is going to come this way. It's going to make 90 degrees. That line that I'm going to calculate is going to make 90 degrees, but it's sharing that same point. So naturally, if I have to use my formula, either way, I must still use the same point. Now that I've determined what that is, so I'm actually finding the gradient or the equation of the normal. Okay, so just substituting the point for x and for y. So this is going to give me that equation. So let's just clean it up and find that equation. So this is y minus 2 is equal to -1/2 of x, and a negative times a negative is a positive. A half times 2 is nothing but 1. Right, so my equation is nearly in y equals mx plus c form. So y equals to -1/2 plus 1 plus 2 if you bring that 2 over. So the equation of the normal at A, the equation of the normal at point A is going to be y equals to -1/2x plus 3. And you would see that I have done that because this here I felt like, let me introduce the graph. So here is the equation of the normal. So once you see that, the angle that is formed here, that angle is going to be 90 degrees. So let's just see if I can still do that. So maybe we find a point somewhere over there. Okay, well, it has to be a reference point. Okay, so let's just go back and let's introduce a point. Let's say a point here, and let's say we introduce another point there, just to show you that that angle there should be angle DAE. So that whole angle on the other side is 270, so this angle here inside here has to be 90 degrees. Okay, so let's just remove that so we don't need these unnecessary points. So this angle here is 90. So this is the tangent and this is the normal, or this is the tangent and that's the normal, and they make 90 degrees and they share the same point. That equation that I have worked out from before, which is -1/2 of x plus 3. You can see it cuts at 3. Now, very important, if we go back, so we have the equation. In this particular case, they wanted us to determine the equation, the curve at A. It cuts again, the normal to the curve at A intersects the curve again at B. So what it means, if I go back to the diagram, it means that the normal, which is this line that comes here all the way, it cuts the curve here. And this point where it cuts the curve, that is where our point B will be. That is the point. So what we are essentially looking for, we are looking for the coordinates, and you can already see the coordinates is going to be negative 0,5, and the other one there will be between 3 and 3.5. So I have it already there. So that is the coordinate that we are looking for. So how are we going to go about finding this coordinate? So let's go back and use our algebra. So I'm going to just continue. So what we know, remember, we're trying to find the coordinate. We have our gradient. So when it says intersecting at the curve, so the equation of the curve, remember the equation of the curve, it was nothing but y equals to x squared minus 2x plus 2. Then the equation of the normal that we just calculated from before was y equals to negative a half of x, okay, plus 3. So basically it's this equation over here plus the curve. Why is this important? Because we're going to solve them simultaneously. So we're going to solve them simultaneously. So we're going to say solve these two simultaneously, because the curve and this normal, they meet at a certain point B. So for us to find that point, we first have to solve them simultaneously. This is going to allow us to find values of x. So basically it's the curve that I have over here that I'm equating to that line over there. So this is what we're going to do. So we're going to find the x value. So we're going to find an x value of negative 0.5 and another one, because this thing becomes quadratic. But we already know what the other one would be. We already know this point, the x value is 2 and the y value is 2. So if we find an answer of x equals to 2 and the other answer x equals to negative a half, then obviously x equals to 2 is not the point we are looking for point B, because essentially we are looking for the coordinates of this point. Are we together there? Right, so let's just go back then to see how we can find this. So we equate the 2 and this whole thing becomes a quadratic that can be solved. Now let's just go ahead and clean this up. So it's x squared minus 2x, so this is going to be plus a half x, of course, then it's plus 2, then minus 3, obviously giving you 0. Okay, now this is gonna give you x squared minus 2x. Now here's the thing, minus 2 plus a half. So we can just clean that up. It's always advise the learners that they should not make that mistake whenever you're working with this type of like term. So it's negative 2. So basically what I'm looking at this term and this whole term over here are like terms. So I can, the same as the numbers are. So I can actually clean that up. Okay, so this is at negative 2, then plus a half. So plus a half, what does that give us? Of course, it gives you negative, or negative 1.5, negative 3 halves. So I'm just going to leave it as negative 3 halves. Okay, so that is negative 3 halves of x. And then obviously 2 minus 3 is nothing but negative 1. We're very close to cleaning that up. So we do not like that fraction. So what we do is that denominator, we're going to multiply each term by 2 on the right as well here. So eventually I have 2x squared. Here is going to be now minus 3x, because the 2's they cancel, and minus 2 is equal to 0. So this should factorize, and I hope you are very much aware how to factorize this. So I'm just going to get straight to the point. So it's 2x plus 1, and then you have x minus 2. And this, you can use the formula, but it's just too much work. Letting each of the bracket equals to 0, because naturally if you multiply two things and they give you a product of 0, it implies that one or the other is equal to 0. So here you're going to have 2x is equal to negative 1. So let's just finish this one, for example. Then x is equal to negative a half, or x is equal to 2. Now we know this one already. This one was point A. So this is the value that we are looking for, the x value of our point B. As you can see from my graph, negative a half. So we now have to find that 3,25 or 3 and 1 quarters. So what we do is we take this x value and either substitute it in the curve, because the curve pass there, or we substitute it into the linear in the normal. So it's always better than to do that. To find y, we will say, let me just include a page. Let's say page, pen page. Okay. So this is what I know. I know my linear one is y equals to negative half x plus 3. So let me just go write that one down. So the linear one is y equals to negative a half x plus 3, and I know that my answer x is negative a half. The other answer was x is equal to 2, which is the one that we do not look for, because this was point A. So in order for me to find the y corresponding value, because you need that in order for you to have a coordinate pair, you are going to substitute that x value, which so happens to be negative a half as well, into this to find me the corresponding value. So doing that, of course, you have, grab your calculator so you do not make mistakes. So you have negative 1 half. Well, of course, you're going to multiply that again by negative 1 half. And then you're simply going to add 3 to it. What does it give me? Of course, it gives me 3.25, okay? If you want that, or if you want the decimal value. Can you see it's 3.25? So I'm going to have that answer as 3.25. So naturally, my point B is negative 0.5, which is this value over here. And my Y value is nothing but 3.25. And clearly, you have seen this for my diagram. And so let me go back to the diagram again just to show you. So that's what I have over there. Does that now make sense to you? All right, let's go to the next question. Here it says the tangents A and B intersect each other at C. Find the coordinates of C. Now, this is very important for the purpose of illustration. Let's quickly write down what we know. The tangent at E, the equation of the tangent at A was nothing but y equals to 2x minus 2. Okay. Then what we now need to find is the tangent at B. So we need to know what is the tangent at B. What do we know? We know that point B from our previous work had, this was the coordinates, negative a half and 3 and 1 quarter. Okay, and also I'll use the decimals. So what is it that we also know? When x, okay, and you need to follow, when x is equal to negative a half, when x is equal to negative a half, we need to go back and say dy dx. Remember what was our gradient formula? dy dx, dy dx from our previous work. Because when I was introducing to you this concept, I specifically said that the gradient formula, dy dx, right all the way here, the gradient formula, which is 2x minus 2, do not confuse that gradient formula with the equation of the tangent. This formula, dy dx, allow me to find the gradient of any x value on the curve. So I'm going to say dy dx equals to 2, and I'm going to take that new x value and input it here in order for me to find the gradient of what I'm now looking for. Okay, so let's just go back there. So, my goodness, just hope. It's going to be a slight issue, but just bear with me, okay? Right. we are just going to take off where we were, and hopefully we didn't lose out too much. This is restore our work. Good. Let me just go back to where I was. Just make this a little bit smaller. Just want to go back to here we are. So what we're saying, dy dx is our gradient formula, and it happens to be, our gradient formula happens to be 2x. It happens to be 2x minus 2. This is our gradient formula. So when x is equal to negative a half, we input it in here. So this is going to allow me to find the gradient at point B. Now let me just go back to that curve. Can you see where point B is? So if I have to draw a tangent line, that tangent line is going to have a negative gradient. Do you agree with me? Because it has to go something like this. And what we are essentially looking for, we're looking for that line. So this is what I'm busy with. I'm looking for that line. So first I'm going to find the gradient of that line. And to find the gradient of the line, I must use the derivative function. Okay, and then input that x value that I got. So it's going to be 2. Then you have minus 1 over 2 minus 2. Okay, so these 2 times that is going to be negative 1. Negative 1 minus 2, obviously that gives you negative 3. So the gradient of this is negative 3. So the gradient, that equation is going to be y equals to minus 3x plus c. Maybe I should leave it like that so you can understand. So how do we find that plus c? Again, we substitute our point B, which we know it was negative a half and 3 and 1 quarters for x and for y into this formula, and we can calculate what it is. So this is nothing but 3 and 1 quarter equals to negative 3, and x is negative 1 half. So this eventually will give me the value of c. And if you were to play around with this, you would see that the value of c is nothing but 7 over 4. So, therefore, the equation, okay, of the tangent at B is y equals to minus 3x plus 7 over 4. Are we together? So we're going to draw this on the graph so you can see how it looked like. So you will see that I have it already, minus 3x plus 7 over 4. So that is beautifully done. Now what they are looking for is these two tangents, they intersect here, and that point they intersect is called C. What is it we're looking for? We're looking for the coordinates of this, the x value, which is halfway between 0.5 and 1, and the y value, which you can see from the grid, you can see is negative 0.5. So these are the coordinates that we are now looking for. So what do? We are going to take these two tangents and we are going to equate them to each other. Okay, so we're going to solve them simultaneously. So that means you're going to solve the tangents simultaneously. So say solve the tangents simultaneously. So the one that we had, we know y equals to 2x. This is 2x plus 2. The other one, the tangent at A, let's just make sure from my graph. What was that equation? Well, it was 2x minus 2. Okay, or we can go back and find that tangent, the original tangent, all the way back. What was it? I wrote it down, just don't want to write down the whole thing. Equation of the tangent. Of course, the equation of the tangent was nothing but equation of the normal. So equation of the tangent all the way up here. The equation of the tangent is nothing but y equals to 2x minus 2. Right, so we're going to take that equation and we're going to take this one, the other tangents, and we're going to solve them. 2x minus 2. And the other one is y equals to the one that we just calculated, minus 3x plus 7 over 4. So if both of them is y equals to, we can just go ahead and just equate the things in terms of x. So what this allows me to do, I'll be finding the x value, and then to find the corresponding y value, I'll take my answer for x and substitute in any one of these two to find that, because we're looking for the coordinates of point C. Right, let's have the like terms together. So 2x plus 3x, and then you have the 7 over 4 plus 2. Okay, right, so if you were to clean this up, this gives you nothing but 5x. Now remember, this is the same as 3 and 1 and 3/4. Okay, you can use your calculator if you want to. You can say 7 upon 4, add 2 to it, okay, because you get 15 over 4, or 3.75, okay, 3.75. So I'm going to leave it as 15 over 4. So this gives me 15 over 4. Right, so to find that x value, we are going to say, x value will be that 15 over 4. Of course, you need to divide it by 5. So we go back and we divide our answer by 5. Okay, so that is 3/4. Okay, so x is nothing but 3/4, or 0.75. Now that we know what the x value is, we want to find the corresponding y value. So I'm going to use this formula, the y equals to 2x minus 2, or I can use the other one. It's totally up to you. Or you can use the other one, y equals to minus 3x plus 7 over 4. You're going to get the same answer though. Okay, so in order for me to find out the y value, so y here will be, that's 2, and then that is obviously 0.75 minus 2. Okay, so 0.5 times 2, whatever that answer is, minus 2, of course that gives me negative 0.5. Can you see that? Negative a half. All right, so that gives you negative 0.5. So that coordinate of C, where these tangents are intersecting, is negative 0.75 and negative 0.5. This is what we're looking for. And let me show you on the graph. Can you see that? I have it exactly like that. All right, and that's what we were looking for there. Clear. So that is where they intersect, and that is what we were looking for eventually. Okay, so you can just bring that in also, so you can know that is 2.2. So hopefully when you see the grid like this, then it is much easier for you to assimilate the information. Of course, that same grid, I have it over here. So whenever you are looking through the video, you can of course, pause the video and have a look and see what I did over there. All right, let's go to question 4. So there are a lot of questions. I'm going to do them in parts. So this is part 1 of my work on differentiation. It says the function f. Now I'm not going to draw graphs for all of this. It's just that I believe some of them were helpful if we're doing that. Okay, so this one is going to be the one that I'm going to do, perhaps, where I'm going to just show you how that graph looks like. Anyway, the function is defined for f of x, which equals to x cubed plus 2x squared minus 4x plus 7 for x is greater than or equal to negative 2. So basically this is a cubic function. Showing all the necessary working. Determine whether f is an increasing function. Increasing functions. Remember, when functions are increasing, it means the gradient is greater than 0. Or decreasing functions, it means the gradient is less than 0. So that's what we're going to do. So the fact that we have to do that, we'll have to differentiate that. So that is f of x. So f dash of x is going to be 3x squared, means multiply and reduce 1, plus 4x multiply and reduce 1, minus 4 multiply and reduce 1. The derivative of that 7 is 0. So what I have essentially is the derivative function. So let me just maybe leave this in infected form. Okay, so it's 3x minus 2. You don't have to, but I'm just looking to do that. It's much quicker. So I'm going to do a series of tests, because it says the function is defined for values of x that are greater than negative 2. So let me look negative 2 or equal to. The moment I put greater or equal to negative 2, the moment I put negative 2 in here, it's going to give me 0. 0 doesn't really tell me anything. It just tells me that there is a stationary point. Okay. So I'm going to just do a series of tests. So let's say any value for x, let's say greater than negative 2. Let's take a value, let's say let x be equal to 0. And once we input, because it's a gradient function, I want to see what the gradient would be. Is it a positive number? Is it a negative number? If it's a positive number, if the number is greater than 0, then we know it's an increasing function. Okay, that's why I do not say or equal to negative 2, because negative 2 will make it 0. If it's going to be a negative number, then it will tell me this is a decreasing function. So I just randomly took any number that's greater than negative 2. Of course, I could have taken negative 1 as well. Okay, but I will not go below that because the function is only defined for x greater than or equal to negative 2. Now, if you go ahead and you put negative 2 in here, okay, that is going to give you 3, negative 2, minus 2, negative 2, plus 2. Well, guess what? You get not there, okay? And you're going to get, just want to make sure, I said let x be 0. My goodness, and I go ahead and I choose the wrong value. So if I put 0, so if I put the 0, what did I get? So that's going to be negative 2 times 2. Well, I get negative 4. So that implies the gradient is negative 4. So when the gradient is negative 4, what does it mean? So with gradient, if m is less than 0, as in this case, then this is essentially a decreasing function, okay? A decreasing function. Let's take another value. So let me just write down my derivative function again, the way I wrote it now. So 3x minus 2 as well as x plus 2. Of course, you can use the other one that is not affected. Let me take another value of x, okay? Because we're looking for values of x that is greater than negative 2. So let's say x is equal to 1, okay? 1 is also a value that is greater than. So basically everything, okay? Let's suppose and then input 1 into that gradient function and see what it gives me. So it's going to be 3 times 1 minus 2, open bracket, 1 plus 2. Now, of course, this is going to give me, that's 3 minus 2, that is going to be 1 plus that. So it gives me 3. What do I realize? The gradient is equal to 3. Now, this is really weird. So if the gradient is equal to 3, let's just insert a page, okay? When the gradient is equal to 3, now all of a sudden, because we know that if the gradient is greater than 0, then this is an increasing function. So what does it tell me? It tells me that this f of x, this function, is neither an increasing nor a decreasing function. Excuse the handwriting. When x is greater or equal to negative 2. That's the conclusion that you are arriving at. So if you were to look at that graph, because I have the graph, of course, so from here where it says it's defined, okay, from this point onwards, because this function is defined from greater than negative 2, and I chose a value, okay, and when I choose a value, I'll see, here, look, the function is decreasing. So here the gradient will be negative, so up to this point, the turning point, the function is decreasing. Guess what? If you input values like I did, I put 1 in and I can put 2 in, all of a sudden the function is increasing. Okay, so you can't now say, you can't assume and say, wait, this is a function that is increasing. There's places where it's a decreasing function and there's a place where it's increasing in that given domain. Okay, question 5. Now, question 5 is also giving you issue of a curve, so I'm not necessarily going to sketch this one, okay? So you have the objective. It says a curve has the equation y equals to 3 plus 12 upon 2 minus x. Find the equation of the tangent to the curve at the point where the curve crosses the x-axis. When something crosses the x-axis, y will be 0. So basically, you will have some x value, but a y value that is 0. So in order for me to do that, we have to find the equation of the tangent. The moment you see word tangent, you need to find the derivative. Okay. Once we find the derivative function, we are going to take that derivative and let that derivative equal to 0. So first, before I explain that further, let's take this function and just clean it up a little bit. So it's 3 plus 12, and then I have the 2 minus x over here, all raised to the power of negative 1. Okay, so you should be able to derive this from here on. So dy, dx, the derivative of, this. In fact, before I find the derivative, it's very important, this function, for you to realize something. And there was no need for me to do that. Okay, so I could have still left that function in its original state. Okay, we are now back to that same place. So we're just going to close it and we're going to come back to it again. There is something that on the stylus, and if I touch that on the stylus, it obviously makes a little bit of an error. Stylus is the pen that I'm using to write on the graphic tablet. Let's restore our work. Okay, so before we do the derivative stuff, this y equals to 0. We want the equation of the tangent to the curve at the point where the curve, so this curve crosses the x-axis. When the curve crosses the x-axis, its y value will be 0. So I'll be using this equation of the curve, and I want to find the x value. Otherwise, I cannot find the derivative because I need to find the derivative at a certain value where x is equal to a certain value. Does that make sense? So let's say y is 0, so that's going to be 0 equals to 3 plus 12 over 2 minus x, and I put it in brackets. Now, this here will give me, and it's very important that you realize this because we do not like this fraction stuff. You are going to multiply both sides of the equation by 2 minus x. So basically, this is algebra. If I multiply here by 2 minus x, I multiply here by 2 minus x, and I multiply here by 2 minus x. That's where we are. Well, 0 times anything is just going to be 0. And that will be 3. In bracket, I'm going to have 2 minus x. And guess what happens? You are just going to see an answer of 12 on this side. And the reason for that is that this and this obviously cancel. Now, this equation makes a little bit more sense. I'm looking for the value of x. Okay, to do that, we are going to say, wait a minute, move that 12 over. It's minus 12 divided by 3, it's going to be 2 minus x. Okay, please stick with me here. This is straightforward linear equations. So this is minus 4 minus 2 is equal to minus x. It's minus 6 is equal to minus x. That gives me that x is equal to 6. Good. Now that we have our x value, we can now find the gradient at that point where x is equal to 6. So this also implies I want to find my derivative function. So my function was nothing but y equals to 3 plus 12 upon 2 minus x. So let me just clean it up then. So it's 3 plus 12, and then in brackets it's 2 minus x raised to the power of negative 1. Now it looks kind of juicy, I can actually find the derivative function, and then I will say when x equals to 6 into that derivative function, that will give me the gradient. Reason for that is we're looking for the tangent, and we're eventually looking for the equation of the tangent, so I need to find the gradient. Okay, so dy dx, the derivative of constant is 0. That multiply with that is negative 12. Then you have 2 minus x, that becomes negative 2, reducing 1. Then you multiply using the chain rule with the derivative of whatever is in the bracket. The derivative of this in the bracket is negative 1. Derivative of 2 is 0. Then the derivative of minus x is just going to be minus 1. So let's clean this up and see, and I have space for it. So dy dx is nothing. That negative times that negative gives this a 12 positive. And then I'm going to put, because of that negative, I'm going to put this whole business 2 minus x over over that. So it's 2 minus x. Okay, now it's a square. Looks like we have run a little bit out of something. So let me just bring in a new page. Okay, let's insert a page. So the stuff I was writing before, our dy dx is equal to 12 all over 2 minus x squared. Okay, when I'm going to remove the other one. Ha. Now, when x is equal to 6, that will give me 12 over 2 minus 6 all squared, okay? So you're going to have 3/4. Now, what do we know? We have our point. Our point is 6, 0. We have our gradient. What is our gradient? Our gradient is 3, 4. So we can now find the equation of the tangent using our formula. Y minus 0 equals to the gradient 3 over 4 and x minus 6. Okay, this is just going to be y, so it's 3 over 4x, and now here you have 3 over 4 times negative 6, so that's minus 18 over 4. Okay, that's minus 18 over 4 minus 9 over 2 minus 4.5. So that's the equation of the tangent that we were looking for. Now let's go to part B of the question, and I can just as well take this off. You have the luxury of course, luxury of scrolling back, or not scrolling back, but rewinding the video, if I have to say so. Now they say a point moves along the curve in such a way that the x-coordinate is increasing at a constant rate of meters per second, whatever the unit is, meters per second, whatever the unit is. Now, that unit is obviously giving us it in such a way, x going to increase in such a way, so that is nothing but dx dt, because it moves respect to x over a time. So this is dx dt, units per second. Okay. What else do we know? We know from our work that what we need to calculate when we take dy dx, which was 12 over 2 minus x all squared. Okay, when x equals to 4, then this is going to be 12, and that is going to be 2 minus 4 all squared. Well, that is 2 minus 4, that's 2, it's 4, so that is 3. So we know that dy dx is equal to 3. We have dx dt, the unit with regard to the time as it moves along. So we are now looking for dy dt because it says find the rate of change of the y coordinate with respect to the time. So we are looking for dy dt. Okay, so that is dy over here, okay, dt over here. So what do we fill in here? Remember, it has to be the same thing. This is dx, and that is dx. Okay, let's just give this power. Now let's fill in what we have. We know dx dt is 0.04. We don't really now worry about the units. We know that dy dx is 3. So basically, we're just going to multiply that. And it gives us 0.12. Whatever it is, unit or units per second. That's the rate at which the rate of change of the y coordinate when x is equal to that. All right, let's come to question 6. We have another one. So some of these questions are also in your textbook. The diagram shows part of the curve of 8 over x plus 2x. So I've drawn the curve, as you can see. And for values of x greater than 0, so you can see the curve is obviously, you can't have 0 here. If 0 is there, then this curve, because this is the y-axis, and the y-axis, the equation of the y-axis is x equals to 0. And you cannot divide by 0. Naturally, if values of x are negative, then that thing is going to have, another curve on the other side. But we are just interested in values of x greater than 0. Okay? That's how it's defined. They say the minimum, obviously you can see that is the lowest point of the graph, so it's the minimum point. It's represented by letter M. Find dy dx, okay? And then d2y by dx squared. So first derivative is dy dx. So our curve is y equals to 8x raised to the power of negative 1 plus 2x. So I'm going to write it. This is going to help me to find dy dx much easier. So negative 8x to negative 2. Okay, reduce that by 1 plus 2. Right, so let's just clean it up and write it nicely. Dy dx is minus 8 over x squared plus 2. Clear. Now, the second derivative, okay, so I'm going to derive that again, d2y dx squared. So again, just to maybe rewrite what this is minus 8 x raised to the power negative 2 plus 2. Negative and negative, that is going to make it positive 16. Then you reduce by 1 there, so it's negative 3. And derivative of that is 0. So basically, this is then 16x cubed. So that's the second derivative. That's what they were asking. Find the coordinates of M and determine. So first, let us take it step by step. How are you going to find the coordinates of M? You have your formula, y equals to 8 over x plus 2x. They say find the coordinates of x. So just maybe before we look into that, the curve here, the gradient here, okay, because this point, lowest point here now, so the gradient there, the gradient will equal to 0. So we're going to take dy dx, the gradient formula, let it equal to 0. So let's do that. Okay, so let's take the gradient formula dy dx, which we know what is dy dx from our previous work. The first derivative was dy dx, which is minus 8 over x squared plus 2. So we're going to take dy dx. Okay, we have to give you this thing a bit of chance. It's having a mind of its own. Dy dx technology, dy dx, remember it's minus 8 over x squared plus 2. We're going to let that equal to 0, but that's going to give me, it's going to give me the x value of that turning point, where m is the lowest point. Okay, my goodness. So this is a little bit acting up a bit. I think we have did quite a number. Just be a bit patient with me. I'm going to divide this obviously into or 3 videos. So dy dx is minus 8 over x squared plus 2. We're going to let that equal to 0 because that's the lowest point, right, of the graph. So we said it's dy dx, which was minus 8 over x squared plus 2. So we're going to say let that equal to 0. Okay, so that's going to give me the x value of that turning point, so to speak. Okay, that minimum point. Okay, they are saying to you determine the coordinates and the nature of the stationary point. So okay, from the graph, when you see, you know that it's a minimum, but you still have to do something. And in order for us to say it's a minimum, the second derivative should be a positive number. Okay, so when the second derivative, when you do that and we get an answer that's greater than 0, then we know it's a minimum. But anyway, let's first find x over here. So that's going to be minus 8 over x squared. But now we are going to say, let's suppose we multiply, because we do not like this x squared. So let's see if this thing is not going to drop me again. So let's bring in red. So when you multiply here by x squared, here by x squared, here by x squared, you're going to have minus 8 alone here. Then you have plus 2x squared equals to 0. Looks a little bit better because we have cleared the fraction. So eventually this can be written as 2x squared minus 8 is equal to 2, to 0. Then 2x squared is equal to 8. Then x squared is equal to 4. Now we are going to look for the value of x. And the value of x is going to be the square root of 4. And take note, I'm only taking the positive value. The reason is x is greater than 0 from our domain. Okay, so I'm not going to take the negative square root of 4. Now that we know what the x value is, then we go back to our original formula. Our original equation was y equals to 8 over x plus 2x. So the reason being, we now want to know what is the corresponding y value. So you have to take this value that you got and put it back into your original formula, and that is going to give you the coordinates of the m. So that being said, it's going to be y equals to 8 over 2 plus 2 times 2. Okay, that's 4 plus 4, which is 8. Now, safe to say our m is 2 for the value of x, as we have seen previously, and 8 for the value of y. Okay, so that is going to give me that particular answer. We're not done. We now want to determine the coordinates we did and the nature of the stationary point at the part of the curve for which x is greater than 0. So to determine the nature of the stationary point, we take the second derivative being remember the second derivative, well, you can always scroll up or you can do that. So it was d, my goodness, just write it nicely. Second derivative was d2y, my goodness. The second derivative, yes, d2y dx squared, if you remember, it was a 16 positive over x cubed. Now we know what our x value is now. It's 2 cubed, and of course this is equal to 2. And if this is greater than 0, then this is a minimum point. If the second derivative is greater than 0, in this case, then this is a minimum stationary point. Okay, minimum stationary point. Okay, I have a bonus question, and that is where I'm going to end this particular segment of the video. A bonus question on this. So you have got a function y equals to 3x cubed minus 2x plus 1, and then you are given the second derivative as 54. Now just what are we going to do to find the value of x? Right, when you hear things moving, I'm standing and sitting at the same place. So what does d to y dx squared mean? Well, it means that d by dx we have to differentiate with respect to x. Okay, so you look at that, multiplying that gives you that. That's basically what it is. Okay, and if it's cube d cube y dx cube or d3y dx cube, it will be differentiate with respect to x d2y dx cube, and d2 dx squared, and so on and so on. So anyway, what is it that we do? So first of all, we know what the second derivative is, so let's take our function and find dy dx. Okay, that times that is 9x squared, then minus 2. That is the first derivative. So let's do the second derivative. Okay, so what will our second derivative be? It's going to be d2y dx squared is going to be 2 times 9 is 18x. That's simply all that. Derivative of minus 2 is 0. So we know that d2y dx squared is 54, so we're just going to take 18x. And we're going to say let that equal to 54. And now it's simple, you just find 18 times what gives you 54? Well, of course, x is 54 divided by 18, and x is equal to 3. All right, so that was a bonus question, and I'm going to continue with my second part of the video, starting with question 7.